Hi everyone, this is Previn with Pipedream. Today I'm going to demo a new and powerful capability that makes it easy to manage the rate and concurrency at which your workflows process events. In this video, I'll walk you through two demos. First, I'll generate 5 concurrent HTTP requests, and I'll show you how those events are processed differently as I change the concurrency and throttling settings. Next, I'll show you the impact on a real-world example that sends a high-volume Twitter feed to Google Sheets. For this first demo, I've added a Node.js code step that will increment the value of $checkpoint for each event. If you're not familiar with $checkpoint, it's just a variable that maintains state across workflow executions. To start my test, I'm going to run a local script that generates 5 concurrent HTTP requests. Now, since I'm sending 5 events to my workflow, you may think that $checkpoint will be incremented from 1 to 5, but that's not going to happen because I'm encountering a race condition. Since all the events are being processed concurrently, they all read the same starting value for $checkpoint, which is undefined, and then set it to 0 and add 1. So the final value for $checkpoint is only 1. For the next test, I'll limit workflow concurrency to 1 worker, which will limit the workflow to processing 1 event at a time. What happens behind the scenes is that Pipedream queues up the events and triggers the workflow in the order in which the events are received. Since the execution is now serialized, I avoid the race condition, and $checkpoint is incremented from 1 to 5. For the next demo, I'll subscribe to the same events from 2 different workflows. In the first, I'll limit concurrency to serialize the event execution, while in the second, I'll both limit the concurrency and throttle the execution to 1 event every 3 seconds. To kick off this test, I'll just run my local script again. In the first workflow, the 5 events are processed in quick succession. In the second, the events are processed at a much slower rate because I throttled the execution. This workflow level control is really important because it allows you to consume the same events in different workflows at different rates based on the use case for each workflow. For the next demo, let's look at a real-world example where we'll send a high-volume Twitter feed to Google Sheets. I've already set up the workflow and source, so I'm just going to run it manually. When I check the logs, I can see that 78 tweets were omitted from the source. Next, I'll just switch over to the workflow that's listening to those events. What's immediately clear is that there are a lot of 429 errors. What happened is that I hit the rate limits for the Google Sheets API because those events were executed concurrently. And when I go to Google Sheets, I can see that only 10 of the 78 tweets were successfully inserted. So let's clear those results and try this again. This time, I'll both limit concurrency and throttle the workflow execution to 1 event per second. Before I run the next test, I'll delete the events from the workflow inspector, and then I'll navigate back to my source and run it again to retrieve and omit the latest tweets. This time, when I check the logs, I can see that 69 tweets were omitted by the source. And when I go back to the workflow, I can see that the events are serialized and the workflow executions are throttled to 1 event per second. Now that the last event from that batch was processed, I can quickly check the workflow inspector to confirm that there were no errors, and I can confirm that all 69 tweets were successfully inserted into Google Sheets. So I hope that gives you a good introduction to our new concurrency and throttling controls. I encourage you to give them a try and let us know if you have any feedback. You can follow us on Twitter at Pipedream and join our public Slack at pipedream.com/community. We can't wait to see what you build on Pipedream. Thanks for watching.